G'day, Alucard J here, and in this series of videos I'm going to be playing around with noise, Unity's perlin noise. Now, I've got plenty of reference source material that I'll be linking in the description so you can read up on some of the things that I'll be implementing. But for now, this video is just setting up the scene and creating a blank template script that we'll build up on to show different examples of noise. So, got a new project, a new scene, a couple of empty blank folders. I'm just going to turn the lighting off because we don't need any of that. Don't need the skybox, so I'll set that up. And we'll start by creating the script template. I'm just going to call it noise example. So what I'm going to be doing is I'm going to be creating a texture and then applying that to a renderer so that we can see it in the scene view to see what we're making. So I'm just going to set out some variables, and a little bit of a description on what's happening here. Texture. Output renderer. So this will be the size of our texture in pixels. And we can set this in the inspector, but so it doesn't take so long, I'm just going to start with 128, and we'll grab a renderer, which we can set the main texture to so that we can see it. So I'll just call this output renderer. Now I'm just going to be using a quad, and I'm going to attach the script to a quad so I can just automatically assign this in awake. So I'll say if, let's try that again. If there is no output renderer, we'll get component renderer. Yes. Okay, so at the very start, we'll generate the texture and apply it to the renderer using the values in the inspector. So I'll create a function, generate noise. We'll call that in start. And then if we change any inspector values at runtime, we can update the texture. Put get mouse button down. We'll do the same thing. We'll get it to generate the noise, create a texture, and apply it to the renderer again. So in the generate noise function, we're going to be creating a 2D array of our noise, which will be our pixels. So let's create a float array, a two-dimensional array, which will be our noise array, equals u float, and it will be the size texture size by texture size. So we'll make our texture a square, and then we'll iterate through every position in that float and assign it a value. So we'll need a couple of for loops. Start with y. Get the texture size, and then for x. Now there's a reason I've gone y instead of x first, and I'll explain that when we get a bit further along. Okay, so for each value in our noise array, so our noise array, at position x, y, equals get noise. and we'll send it our position. So I better create that function. So this function will return a float. So it'll return a float and assign it to that variable. So float, get noise, and we're taking an integer x and an integer y. Okay, so nothing's quite broken yet. We'll fill this out, but so we'll just return 0 so it doesn't get messed up. Okay, so while we generated our noise, we'll have to generate a texture. So let's create a function for that. So this will return a texture 2D. Get texture, and we'll send it the whole float array 2D. Now, we're generating a two-dimensional array, but when you assign the pixels of a texture 2D, you actually give it a one-dimensional array. So we're going to need to split this array up, put it in one long single-dimensional array, apply the pixels to the generated texture, and then return that texture. So we're going to need the length of this array. So int length x equals array 2D, get length 0. So that'll be that there, index 0 and then index 1. We'll do the same thing for our length y. We get length 1. Alright, so now we know the size of the array we're passing into this function. We can copy this loop because we're going to be doing the same thing, except for that part. And for the iterations, we'll use the length. Okay, but we're going to need an array to store all these values. So int our pixels or our color array. So actually, here's going to be an array of color, sorry. Our color array, our texture colors equals new color array, and its size, as I said, it's one-dimensional, so it'll be length x times length y. Okay, so we've got our array, we've got our 2D array, so we just need to plonk these values into here. So texture colors. Now, what is our index? What are we going to be in this array when we're looping through the 2? So it's going to be x plus y times length x. Wrong bracket. Equals, and we're going to assign it a color based on the float. So we're going to be creating a grayscale image. So let's just say new color, and array 2D x, y, the R channel, and the same thing for the G and the B, and for the alpha we'll set it to 1. So we got all this. Yeah, so we've taken in a 2D array, created a 1D array, we've taken our 2D array values, turned it into a color, and plopped it into our 1D array. So let's create the texture. Equals, well, let's call it something. New texture equals new texture. And give it a size of length x, length y, the format, texture format. ARGB32 and mapping false. Okay, so our new texture, we apply. No, we don't apply, we set pixels. Set pixels, and we see the set pixels takes that one-dimensional array of colors I was talking about. So, texture colors. Okay, and now we apply. Now that we've created a texture, we can return it. New texture. Okay. So let's just see if everything's working first. So we need to apply it to our output renderer. So let's just check, because in case this script is not attached to anything with the renderer, if this fails here, oh look, made a mistake. Our output renderer equals, let's just say, object. There we go. Okay, so if we have no output renderer, we'll get the component on this game object that the script's attached to, but then we check down here as well after we've generated the noise array, and we can call back the texture from the noise array. Say if output renderer, then output renderer material main texture equals get texture using our 2D array that we created here, our noise array. Okay, and like I said, let's just change this to a random dot value. So we'll get non-coherent noise, like there's no interpolation between the noise values. Alright, let's see if I completely broke that up. Texture does not take as constructor. Oh, new texture 2D. Whoops. There we go. Okay, so like I said, we're going to create a 3D object quad. Line that up. We'll bring the camera in closer. 4, 2. We'll set the Y to 0. Okay, pretty decent. And I'm giving it away here, but our first example will be basic perlin. So we'll attach that script there. Okay, we've got our texture size, we've got no output renderer. Let's just save the scene. And hit play. And wait half an hour for Unity to decide it wants to do something. And there we go. We can see there that we just get a whole bunch of random values for each pixel, created a texture out of them, and applied them. What I might do as well is I'll create a unlit material. So we'll just say unlit texture. And we can apply that texture to the material. So unlit texture. Okay, we'll use that texture on our quad. There we go, so the lighting is not affecting it. Okay, so it looks like everything's working. We'll save the scene there. Now, just as a precursor to what we're going to be doing, I'm going to create an enum for the different type of noise types that I'm going to be showcasing. Let's say noise type. And then we'll have a public enum Oh. And as I said, going to look at basic perlin. Going to look at fractal Browning motion. Going to look at turbulence. And it's not actually a noise, it's more of a filter, but we're going to look at exponential. Exponential. Alright. So let's create a variable that we can assign that in the inspector. Public noise type equals noise type. Let's just set the basic perlin to start with. All this can be modified in the inspector. So if we're going to have an EMUM of different type of noise, in our get noise, we want to be focusing on those different types of noises. So let's just create a float noise. Let's just say it equals 0 at the moment. And then we'll do a switch on our noise type. Case noise type basic perlin. I'm going to say our noise variable that we've declared here equals, and we'll call a function. And we'll also send it our x and y values. So we're going to need to create that. And that returns a float, because we're assigning it to our noise value here. And so here, just so nothing breaks, we'll just return 0 for now. Okay, so that's taken care of one case. Noise type fractal. Let's call our fractal perlin. So we'll just copy this function here. Call it fractal perlin. Our next one was turbulence. Now we'll be using the fractal perlin for that. So that made another one here. Turbulence, and finally exponential. And this will be an exponential. This will be slightly different, because we're going to get our fractal noise, and then we're going to modify it with an exponential filter. So this is going to be noise equals fractal perlin. I'm getting my head of myself, but none of this will make sense at the moment, but we will get there. So noise equals exponential filter on the current value of noise that we get from the fractal. So let's just create that too so it doesn't mess up. And this time we'll be taking in a float, because it's the noise we already calculated. Float that one. Alright, so then after we've gotten our noise, we will just simply return noise. And again, I should have done that. Let's just call these random value. Random.value. Just to check everything in the inspector and see if we've broken anything. Okay, save that. This is interesting. Header. What have I done different now? Oh, yeah, because we can't do it to the enum. Alright, so let's declare the enum first, and then on our variable we'll give it the headers. You happy with that, Unity? Yes, you are. That makes sense. Okay, so now we've got an enum here that we can choose our different types of noise, and then we'll have some values after it that we can play with. Let's see if this works. So if I click in the inspector, we'll just keep generating different noise. At the moment, this will do nothing, but if we go to a different noise type, okay. Alright, so that is the skeleton and actually a lot of the precursor stuff that we're going to be using. And then from now on, as I demonstrate each example, we're just going to fill in these functions to give us different noise outputs and see what they generate. I'll post this, get the date. I'll post this in a paste bin so people starting on the next video can start off from this. So yeah, see you in the next video.